Hello, everyone on Twitchland, and welcome to Howdy Partner, a weekly Twitch series highlighting the AWS Partner Network partners that have built innovative and cool solutions. My name is Bhavye Sharma, and I'm a Partner Solutions Architect here at AWS. My job involves reviewing the architecture diagrams and architectures developed by the amazing community on AWS and helping them improve their solutions using the best practices. Today, I'm joined by my co host Parvinder. Hey, Parvinder, could you go ahead and introduce yourself to the audience and tell us a bit more about what we're going to be showcasing today?
Hi, Bhavye. Thanks, and thanks for inviting me. Hi, everyone. My name is Parvinder Singh. As Bhavye, I also work as a partner solutions architect with AWS. But predominantly, I work closely with the product teams of independent software vendors, ISVs, like EDV, where we identify and build joint solutions that add value to our customers. Now, today, as a session, we will be learning how EDB is helping customers on migration journey from Oracle to PostgreSQL, and then also supporting mission critical applications from enterprises. EDB, if nobody knows, like EDB is an open source database management system. What it does, it enhances and extends PostgreSQL for enterprise users. EDB also aims to make PostgreSQL suitable for mission-critical applications, as I mentioned. It adds performance, scalability, and security, along with compatibility for like proprietary databases like Oracle. Now, before that, or we go into detailed information, I will pass it on to our next speaker, Tom from EDB, who was a senior client engineer till yesterday. Congratulations, Tom. He's been promoted to a principal client engineer, and he will provide an in-depth session on EDB's capabilities. So, Tom, before you start, how's the weather in Minnesota?
It's so funny you ask because I actually have a little snippet here. If everybody can everybody see my screen now?
Not yet.
Okay. Is that something? Yeah, there we go.
No. Yeah.
Yeah.
So it's worth noting two
Oh my
things.
God.
First of all, this is being called the Howdy Partner. I like to comment that I grew up in the Midwest in Oklahoma, and Howdy is a proper way of saying hello to everybody. Secondarily, there was a moment where I had to travel last winter, and I paid my daughter $100 because I wasn't going to be around to shovel. Well, lo and behold, it did snow. I gave her the $100, and actually, after my Nest doorbell captured this video, her text to me was, "It wasn't enough." So, for the moral of the story here is, no matter where you are today, at least you're not my daughter last February shoveling this. So I do want to, take the moment to thank everyone for inviting me here today, and also when I say howdy, and I mean it in the most sincerest sense, and I'm a very visual learner and visual teacher. I will not be having everyone stuck in PowerPoint all afternoon or evening or morning, wherever you may be. It's worth noting here that as I'm up here in Minnesota, way up north here, that honestly, the only thing north of Minnesota is Winnipeg and then this thing called the North Pole. I did grow up here in Oklahoma. It looks like a big pan. So to me, howdy is actually an appropriate way of saying hello versus all the rest of y'all. So, but in the spirit of that, wanted to get into there is two fundamental things I want to make sure we cover off on when it comes to what EDB brings to AWS, along with what I found is a critical success criteria. I work with clients, from anywhere from 2 to 10 a week in trying to understand how do we help them really make the cloud be this successful journey, this successful next platform for them. And I think it's worthwhile that we talk about the two main things in today around how do we help them get off of what they're on today, usually something like Oracle, along with if you're going to get to the cloud, how are you not giving up things like business continuity and just the runs all the time aspects you get used to in your data center? And that's what EDB brings to the forefront for everybody. I would like to highlight, and it was kind of mentioned a little bit earlier, but we are the largest contributors to Postgres in the world, based out of the East Coast, out of the greater Boston, Massachusetts area. And we have a global presence here, and we are we're a big and growing partner of AWS's. And when I say contributor to Postgres, and again, I'm going to kind of close out some of these silly things. Let's get to the heart of it all. If you think about Postgres and where it started coming out of Berkeley in the mid 90s with Dr. Michael Stonebreaker and that team, it was an open source database from its first day in development. In fact, it was open source before the world knew what open source was. It was called free back in the day. Well, but to truly evolve open source, you need to have a core team. And if you look here at the core team, 3 of the 7 seats of the core team are EDB between Dave, Bruce, and Peter. And then as you scroll down contributors, you see a litany of other people in our engineering, CTO, and even our support organization who are contributors to Postgres. But it isn't just about Postgres either. This is about things like monitoring, platform, high availability, backup recovery, all those things you need to make a database be successful. I would challenge that any one open source project of Postgres, that someone is trying to do real work on, is actually using probably 5 or 6 or 7 open source projects. So it's really the sum of it all. So thank you everyone today for your time. I also, so being that I grew up in Oklahoma and Howdy is kind of my way of saying hello to everyone, I also have a minor in statistics and I love research. And I especially like research in which I can go and ask questions and understand and look at trends, because what we all appreciate over time is what changed from that time yesterday to this time tomorrow. So I do some research with a partner we have called Platform 3 Solutions, and the 4th annual research just came out a couple of weeks ago. And one of the questions we asked, which I like being provocative, because I think, first of all, and I was joking with my AWS friends before we got on the call here, this could be kind of boring. So let's kind of make this spicy and fun here on a Wednesday. And if you're going to be provocative, let's talk about what people don't want to do. And I think this question says it all. We're looking to reduce our spend with, and over the last 3 years, you see a consistent desire for people to stop paying for Larry's Island, as I like to call it sometimes. But you see other vendors on here too that people are trying to get off of. And I think that's what's happening in moving to the cloud. They're moving from vendor-centric technologies, SQL Server from Microsoft, Oracle databases, DB2 from IBM, and they're looking to move into more of a standard open source platform, because I would challenge for everyone on this session today or listening to it, if you're really going to move to the cloud, you need to be able to do 3 to 4 times as much with 3 to 4 times less cost than what you're doing it for today. So how do we make that happen when what you're on is something like an Oracle RAC or Oracle Exadata box, and you have all these people around it keeping it running, and you're saying, hey, let's go to the cloud. So, where this starts is we have a version of Postgres we call Advanced Postgres. Advanced Postgres is where we take open source Postgres, and every time open source Postgres comes out, we add to it its ability to add 2 fundamental things. There's a lot on the screen here right now, but it's really the middle part where, first of all, we make it look and smell like Oracle. So for those of you who are Oracle people out there, you know what I mean. Packages, views, store procedures, triggers, DB links, functions, utilities, indexes, data types. There's a whole lot of things that make people kind of get stuck on Oracle. We took all of that and put it into the core optimizer of Postgres, but also maintaining that Postgres compatibility as well. But we also added to it, because there's a lot of things Oracle brings or we're used to on-premise that we want to make sure we're added to Postgres around security, both physical and logical security. Physical security are things like SQL injection protection, but logical security like maybe data redaction. But we've also added into things like transparent data encryption, so that you at the database layer can control the encryption of what you have at rest behind Postgres. So with that, it doesn't really matter unless we give you other tools to make it successful. What do I mean by other tools to make it successful? So if you're on Oracle today and you're looking to get to Postgres tomorrow, there are moments of things you need in that journey to both assess, kind of from left to right, assess, move the data, compare that the platforms are identical, so when you cut over, you don't lose anything. And then while you're doing regression testing, how do we automate that regression testing? It's worth noting too that we here at EDB, we're the largest providers of education to Postgres in the world. In fact, my invitation to everyone is, if you happen to go to EnterpriseDB.com, create a logon into EnterpriseDB.com and you'll have immediate access into our training portal. And I'm going to assume that I don't need my phone and my Okta key and my retinal scan and a pint of blood. No, I do not. Thank you very much, ladies and gentlemen. But if you go in here, you will notice that our on-demand courses, so we have certifications, we have virtual labs, live labs, but all of our on-demand courses are this amazing price of free for Postgres. And this gets really deep into Postgres. There's a lot of things in here for you to take in. We do Postgres. This is for kind of your self-paced types of educations. Like I said, we do virtual workshops. We can even, for your organization, do live workshops. But with that, you can also go in and get certified on things. We do certification through a third party called Freeman Education. They're one of the largest certifiers of people in the world for technology. So if you want to actually get certified in Postgres, we bring that to you as well. But this journey of getting off of Oracle and onto AWS with EDB and our big animal offering starts here. Now, as I said, I'm not going to make us all get stuck in PowerPoint all day. Let's go into it. So if I think about our offering in the cloud, and this is our big animal offering, this is our UI to the offering. We have, the nice, pretty offering of a UI, which does kind of take a hint of a T-Mobile store, fuchsia color up here a little bit. And
Tom, before you continue, could you just maximize the screen?
Yes,
maybe,
absolutely. That's right. I guess things get a little, let's do this. Let's do this. Is that better?
Yeah, that's better.
Perfect. See, now, mind you, I am one of the more elder people on the phone, but I have cheaters on. These young men don't have these problems. But what we have here is this ability to provision up Postgres in your AWS account. You see here I have a US West 2 entity where I have a primary and a secondary running advanced Postgres. And what I'm going to do is I'm going to start the journey by saying, all right, well, let's start with anyone out there who, first of all, wants to prove me wrong would start by saying, well, let me assess what I've been doing in Oracle. It's been running for 20 years. Odds are the people who made all this stuff retired or left. So I'm going to go into my migration portal. In fact, I'm going to get out of this, and since we have the time to do this, if you go back to EnterpriseDB, with those credentials you created for the training portal, you also see there's a migration portal. You go into the migration portal, you take this DDL extractor file, and you're going to run it against Oracle. And this DDL extractor file is really just going to look at what's going on in your Oracle environment. And it's going to give you one file at the other end, and you're going to start a project. I'm going to say this project is my Oracle migration. I'm going to say it's on Oracle 12 because, oh my gosh, Oracle 12 went into life earlier this year. We got to get off of it. It's a high priority. And I'm going to go grab this file that came out of my Oracle environment, and I'm going to hit create and assess. Well, by hitting create and assess, it will grab that SQL file, upload it into this assessment portal, and it will quickly identify what passed, what was automatically repaired, and of course, there's a failed. So of course, now all of the antagonists listening to this or watching this can say, well, Tom, you said it was compatible. Well, there's always, edge cases of things that are going on. I've seen clients who had materialized views and they deleted the original table, or they had a lot of things that were just really broken, but Oracle still let them do it, and we uncovered it using the assessment portal. It's worth noting, too, when we say system repaired, there's little things like in Oracle, they love their double quotes. In Postgres, you don't need double quotes. So we clean up syntax along the way. But this isn't just some sort of pipeline tool, because everyone could use, the DMS from AWS, God love you, or if there's OR to PG as your tool of choice as well. But those are getting you running all of this through the schema and the data types, kind of through that sausage grinder and make them fit into community Postgres. What I'm saying is, to what degree do you change nothing in your Oracle environment and move it into this environment? And it also gives you a very interactive way to drill into what's going on, whether it be the different types of specific views or triggers or packages that exist inside of Oracle that we can lift and shift and move into advanced Postgres with no changes at all. Again, I want to state this is the big difference, because we all appreciate swim lanes here in our world. This is a swim lane where if you're trying to get off of Oracle, this makes it very easy. But again, the antagonist on the call is going to say, but Tom, there's something red here. What is the problem? Well, in this case, we identify it in this view where it specifically states that it's an explicit typecast, please tell me what you want the data type to be. So if I happen to go in here and if I don't know Postgres or I don't know really what's wrong, you could go in here and look at up explicit typecast and we'll say, well, just, change it to where you have put the : int on the tail end of this, hit reassess, and now I've moved myself to being 100% compatible. Well, now there's two things you can do from this assessment component, because anybody who's moving off of Oracle and is on this call listening right now on our Howdy partner conversation, you don't have one Oracle environment, you don't have two, you could have dozens or hundreds. So how do you stack rank? Where do you start? And this is a great way to identify maybe where to start based on compatibility. For instance, is it harder to move something that is really complex in 1 terabyte in size, or pretty easy and 100 terabytes in size? I'll take the 100 terabytes all day long because that's easier in my mind. But it's the one where it gets kind of gnarly and ugly and small. But you can also, through this, you create reports. You can have generate reports, because we all have people we report to that need to see some sort of assessment output. So we give you a nice, pretty output. Oh, oopsie. I did go out of that. Sorry, wrong tab got closed, but it saves projects.
I had a question. So I see in that UI that you have, there's some things that are repaired and some things that are passed. So
Yes.
what exactly is the difference between the two?
Yeah, so the past is it required no change to the syntax at all, where what repaired is it's trying to move things into being a little more syntactically standards-based. That was my example where if we went and drilled into the system repairs, you'll see little things like handlers, or like how Oracle loves their double quotes and Postgres doesn't need double quotes. So we'll try to un-Oracleize some of these things. I just made up a word, by the way, un-Oracleize. But the moral of the story is I could then take this and I could even migrate it right to my offering. So let's do that. So right here, I created a cluster called Oracle Migration. Oracle Migration is, I have a replicant in 2 different zones inside of the US East 2 region. I have also PG Bouncer running on above each of those. So as you have RDS proxy inside Amazon to do things, we use the Postgres native tool called PG Bouncer for a connection pooler. But what I want here is I'm going to take this read-write string that exists, and I'm going to go in here and I'm going to say, you know what? I'm going to take this online migration of what I took out of my Oracle environment, and I'm going to put that string here. I'm going to try to remember which one of my kids' names I used for the password and their birth year. That's a joke, by the way. Test the connection. Connection successful. Go next. And then what it's going to do is take out of my migration portal the successful 100% compatible, move it over here into my big animal onto our latest version of Advanced Server 16. And then it is done. And to prove that it is done, I'm going to, for anybody out there who is a diehard Postgres person, this is pgadmin, which is the de facto UI anyone can go download for free all over the world. And you can see here where I created kind of here's my read-write. And actually, I need to hit refresh. So you see here in my read-write, here is now my EDB migration database that exists. Inside that database is the schema for my database that I took out of my Oracle environment. And what it also you can see here is even within pgadmin, you can see that Oracle-esque that was migrated into Advanced Postgres, like the packages, like the store procedures, like the trigger functions. These are all native Oracle-centric syntax running inside of Advanced Postgres. I also like to state that because I had a replicant, I could go out there and look at the read-only replicant, and you can see that that was available for me to look at over here as well in the read-only replicant. So that is the assessment portion. Yes, sir.
There's a question.
Yeah, bring it on.
So questions pretty much on end-to-end and the approximation set of timelines. How much time does it take for Oracle migrations?
I can move, so I just showed you what it takes to move a small to medium size schema database from Oracle into this cloud offering in front of you. Now, of course, there's always going to be those edge cases of things that come up. but we generally find moving things like schema and data can happen in days. Where it gets complicated is when you're doing things like the regression testing of what runs against Oracle out of your code against this advanced Postgres to make sure the three things happen properly. One, did the query works properly, which they will. Two, do you get the same results? And three, is it as performant? And making sure that you kind of run through those things. I did some work with a large auto manufacturer, which have one of their cars in my garage, and we moved about 100 terabytes and 35 different applications over about a 1 year period that represented a large portion of their Oracle estate, and they got it done easily within that time window and under budget. But the reason it takes that long isn't because of the amount you're banging on the keyboard, it's decision making and bureaucracy and the end-to-end things. So if you don't have a bunch of bureaucracy or things in your way, you could do this very, very fast.
So from what you're telling me, the biggest challenge isn't really like the movement of data or trying to conform the schemas that are different between the two databases.
Yep.
It's actually getting the decision makers to agree on what tool to use, how to transform this data, how to get it.
And I find too that organizations can take two approaches to moving things out of Oracle. The first one is we just want to get off of it as fast as possible and just move everything up into the cloud. So if it's 100 terabytes today and it's 30-year-old data, just shove that stuff up into AWS and let's just get off of that as quickly as possible. And that can have consequences down the road, but it gives you the greatest velocity. Where things get more complicated are things like, hey, we've had all these things we wanted to change about the application, or things where we want to go out there and decide maybe we don't want to move 100 terabytes up into the cloud. Maybe we want to archive things. You get lawyers involved and accountants involved, and things get more complicated. So I think the point I want to mention here is generally not what we're trying to do here is we're trying to take more of the technology risk out of it to give you the art of the possible, so that you can decide what is the right path forward for where you're taking this platform into the cloud and getting off of Oracle. You have other compelling events too. Oh, our Oracle EULA is up in 2025 on January 1st. So that gives us, 55 weeks from now to get off of this stuff, right? Sometimes compelling events are as simple as that. You have other clients who's like, oh yeah, we got to get up our EULA in 55 weeks. Oh, we're still trying to figure out what we're going to do. I'm like, TikTok people, right? So but the moral of the story here is in the narrative that we're going through today, and what I'm trying to make sure you can see that we bring to you to help get you off of Oracle and into AWS with a big animal is the opportunity to use our advanced Postgres that is about 90% less expensive than Oracle, by the way, and includes all the tools that runs as a service inside of the marketplace of AWS. And with that, by the way, includes other tools. So I just showed you the assessment part. So the assessment part got me to that was horrible grammar. See, when you have people say howdy to you in their pronouns, we also use words like got in sentences. But we have also tools to help you move the data. So moving a data comes in two primary fashions. You can do massive lifts and shifts using a migration toolkit, and then you can also do heterogeneous replication. So our migration toolkit can move all of the things that are Oracle-esque into our advanced Postgres. Now it will work with other databases as well, including Sybase SQL Server and MySQL. And then we also have heterogeneous replication. So the reason this is important to understand is when you're moving an Oracle workload into the cloud and it's still an active tier 1 workload, you want to do the massive lift and shift using tools like this, which are highly parallelized and will move a lot up into AWS quickly. But then you need to have some sort of change data capture replication model so that before you cut over, you have everything you need. But with that, we also then have a tool called Live Compare, because before you cut over, you don't want to lose data. You don't want to use fidelity on any of this. So Live Compare will actually compare your existing Oracle environment against your advanced Postgres environment up in Amazon and identify if there is anything different. And I don't mean select count star on this table for 10 million rows and select count star on this one that shows 10 million rows. We actually get down into the data types and into the data itself to make sure that they are identical before you cut over. That's a big deal because nobody wants to be the one who forgot something or duplicated something. because we also then auto-generate, and I say this with the second bullet here on purpose, we will auto-generate anything that has to run against a Postgres environment to make them identical. Because before you cut over, you want zero data loss and zero downtime. So how do we get that to that point? There's also other tools, and for those of you who, I'm not sure if there's a way to poll people on this, but I'm just going to say it out loud. When Stonebreaker came out of Berkeley in '96 with Postgres, by the way, I was there back in the day, so I know this vividly. One of his primary objectives was to make Postgres to be more extensible. That was where the birth of things like object relational came into play. And one of those extensibilities is this thing called foreign data wrappers. So foreign data wrappers give you a way to connect to other data sources outside of Postgres and have that be a way to even do distributed queries, but it's also a way to pull data into Postgres. It's a lot like how DB Links works in Oracle, for those of you who are Oracle-esque in nature. But with that being said, that is, in its simplest essence, what we can do to help really accelerate and take a lot of those risk factors off the table for you when it comes to getting off of Oracle. Nothing against the DMS, nothing against Order PG, but that causes a lot more work to happen, especially if you have a lot of stored procedures and triggers, a lot of packages, and there's just a lot of things that don't exist in Community Postgres that we add into Advanced Postgres. So I'm going to take a pause there to see if there's any questions on that front.
Yeah, before we get into the questions in the chat, I had one technical question about the migration tool that you told us about. So from what I understand, you showed that there's a script, you run it in your host database and you specify the target one, it'll give you a report, and then you can actually do the transfer. So my first question is, where does that actual, do you spin up a new instance to start that transfer? Is it the responsibility of the receiving database or the database that's,
So great question. In the spirit of time, I went out there and pre-created something in our cloud offering. So again, this is our big animal offering that's in the marketplace of AWS. And I went in and I pre-created this Oracle migration environment. But what you would do is, so I have an Oracle environment on-prem. I'm looking to move it up into my AWS account. If I just go in here and create cluster, and I can, let's do this real quick together. In AWS, US West, I'm going to go in. I'm going to call this Oracle Rieger. I'm not feeling very creative right now. Oracle Rieger 1. I'll choose again one of my kids' names because I just like to have passwords I know. And you see right here where it says EDB Postgres Advanced Server. If you make this decision right here, it will install as part of your licensing inside AWS the full rights used to do this Oracle migration tooling. Otherwise, you can choose just Community Postgres and use that as your beginning point, but the Oracle migration stuff won't exist. But if I go here to Advanced Postgres 16, I'm going to go use these nice Ice Lake, 1 and 8. I'm going to use IO2 storage because I need to make sure I get all the performance I need. Yes, I'll do 10,000 IOPS, and I'm sure that's going to haunt me later. A lot like how you can have parameter groups and certain parameters inside AWS RDS. We have these things called formulas, and they come pre-configured with best practices of Postgres tuning parameters. And then, we have all these other things that you can do as well, including things like I can do up to 6 months of backups into S3, vector and PostGIS. I can have a read-only replicant, have the PG bouncer, and then also I can have super user access. I hit create it, and here in about 5 or 6 minutes, I'll have an environment. That is then where I would, from this migration portal, say, okay, migrate to online migration, click here, and I would just put this connection string from Big Animal. So this is just, good old-fashioned database connection string 101 right here is what I was doing. I would take this, drop it in there. Here's my admin database, my username, my password, which is one of my kids and their birthdays, and I test connect, and I'm off to the races. So it can be as easy as that. Of course, I'm oversimplifying things because I'm an IT staff of 1 here in my home office in Minnesota. But, for even any other organization who has a bit of command and control around how they do these things, we want to make it as easy as possible. All right. By the way, I assume if I hear nothing, then what I did was so amazing, everyone's so awestruck that you'll find me on LinkedIn. I'm the only Tom Rieger on LinkedIn in Minnesota, as far as I know. So there is a whiskey distiller in Kansas City called Rieger, but I'm not that family. I'm further up the interstate here in Minnesota. So if anyone ever wants to reach out to me on LinkedIn, please don't hesitate. So that is, if I think about what I was looking to highlight as kind of one of my pillars of conversation today, it was definitely around the how do I remove a lot of that risk and give you the right toolings to get off of Oracle. You did notice that I had some tools that would let me, help get off of SQL Server. I'm going to say Sybase because I'm old enough to remember when Sybase was a thing, and SAP is killing Sybase soon. So anybody out there with Sybase stuff, because what I see, and I said this once and I'll say it again, organizations are trying to simplify their overall database vendor strategy. And Postgres is that database that's really, taking the world by storm. In fact, if you don't believe me, one of the websites that I find that are always interesting for us database people is you go to dbengines.com and you look at their ranking. Now, beyond how they do the ranking, I'll let you look up their method they do here. But please note how Postgres is the fourth most ranked database of all databases in the world, and it continues to go up while people are trying to get off of paying for Larry's Island more and more. But it ranks. Let's see, if I scroll down here, how many databases are there? There are over 420 databases listed here. Postgres is number 4. And it's the only open source relational database. And I say that because, in my humble opinion to Tom Rieger, MySQL is really just a Trojan horse for Oracle. That's not really open source, in my humble opinion. But when it comes to really doing things in AWS and where we're taking this, Postgres is a major play. So how do you get to that idea of the better pricing, the better innovation, and the better terms and conditions to be successful? That's what we bring to the table.
Awesome.
All right. So now, if we're ready, shall we talk about resiliency? Because resiliency is always a fun topic. It's boring, but it's always a fun topic. It's like selling insurance.
Yeah, I'll tell you, like here at AWS, we're always getting more and more trainings and internal trainings that we have to do to learn about resiliency. So it'll be great to learn your perspective and what you have to add.
Let me tell you a story here too. And I think it's a great story that was told because we love to talk about HADR, high availability disaster recovery. And the difference is, so there's an airline that's going through a merger right now who may have a data center in Honolulu. I'll let you decide who that is. And they told us a story about how their data center lost power for 10 minutes. Data center lost power for 10 minutes, and guess what? The generator didn't kick on. So things went down. But by gosh, the power came on and they had everything back up and running normally in under 90 minutes. And they thought they were like victorious in IT because in under 90 minutes, they got everything back up and running again. But it affected the operations of the entire airline for a day and a half. So the executives were pissed. Passengers are mad, baggage is in the wrong plane, mail didn't get anywhere, crews are in the wrong places, planes are for a day and a half. But the IT people says, yeah, but we did it in under our 4-hour SLA. Wasn't that freaking great? The difference there is they recovered from a disaster. What the world wants is to never let that disaster happen in the first place. That is where we have high availability. So HADR, DR is that story where IT thought they won. HA means we never want to be down ever. So let's talk about that a little bit. So we have a technology inside here. Let me kind of close some things up here a little bit.
Another point I'd like to add to what you just said, here we have this, in our training, we were told there's a difference between being reliable and being resilient. So let's say you have like a car, like a Japanese car that's very reliable, like Honda, and it never breaks down and you just have to service it once in a while. That's just reliability. That doesn't tell you anything about resilience. But on the other hand, let's say you have a car and you face a puncture and you have run flat tires that still let you go on even when that puncture occurs. Now that's when we are talking about resiliency and being able to deal with those faults and problems that will happen, like will definitely happen in the real world, no matter what you do. So
And,
it's trying.
and I think there's a desired expectation in moving to the cloud. Again, let's not forget, all of us want more for less. That is a fundamental. Well, if coming into the cloud, I'm already managing my data centers to the point where I can operate in my mind with a very high degree of resiliency and redundancy, then if I'm coming into the cloud, I'll be able to get that and more, but spend less for it, right? So I don't know anybody in technology who gets a bigger budget. There's the downward pressures are constant. And oh, by the way, wait for tomorrow. Actually, I think it was yesterday or today when Intel came out with their next newest chip, right? So just wait until the next new chip comes out, or the Graviton 4 was announced from AWS, right? So because what's happening is, as hardware gets cheaper, I think Seagate just announced a 25 terabyte hard drive. One hard drive, 25 terabytes. Intel processors, you look at, I think I was reading where the latest Intel socket is equivalent to what the fastest supercomputer is in the world in 1998, right? So how do we take advantage of these things? Well, it's a software problem now, is what it really is. And what's also happening is when you move to the cloud, there's another primary expectation the world has. I never want to be on old stuff again. I don't ever want to have technical debt. Technical debt takes on two forms: hardware technical debt and software technical debt. So I don't want to think that I'm stuck on some 8-year-old Broadwell processor from Intel or on some old, stodgy hard drive. But at the same time, I want to make sure I don't ever have to worry about something going end of life ever again. I mean, since the dawn of technology, all of us as technologists have had to worry about, oh my gosh, I have to upgrade the database. Oh my gosh, I have to upgrade the operating system. Oh my gosh, and there's these things that are turning into why people move to the cloud is, well, I'm on Oracle 12 and Oracle 12 went into life earlier this year. So I got to do something because now I have liability, I have risk. So with that, with our Postgres distributor, what we bring to AWS in our Big Animal offering is this opportunity to have cross-region active Postgres. Let me just stop and say that again. You can have a single virtual instance, a data mesh of Postgres running between two regions of AWS that are both actively reading and writing at the same time. So let's take a pause and think about the opportunities that come with that. The first opportunity is extreme high availability. Now, I would never think in the wildest dreams of my life that Amazon would ever have an outage. So I'm going to go back to some backhoe hit the fiber at the wrong place in the network of AWS and something didn't happen. Well, that to me is a catastrophic failure. So how do you handle catastrophic failures? Now, because if I go look at the SLAs of things like compute and regions and zones across the cloud world as a whole, it's 4 nines of availability. So you could lose 52 minutes of your business every year based on those SLAs. So how do you handle the catastrophic? But also, how do you do things like rolling upgrades so that users are never bumped off a system while things are being updated? So you could have one node offline and those users just talk to the other node. And when it comes up online, they get reconnected and they get resynced and on and on and on and on and on, so that you can enable and automate those major upgrades of things like Postgres. One thing about Postgres is minor updates are easy. Going from 16.0 to 16.1 is academic. But to go from 13 to 16 or from 15 to 16, a major update requires a little bit of work. So one of the things about our offering, on top of what Postgres Distributed brings to you from our offering, is we will do the minor and major upgrading for you, and no one's the wiser. And then finally, what about distributed workloads and geographies? You get into all kinds of things, because one of the things about distributed as well is we can give you all kinds of ways to control what data goes where. because the world isn't just one big hard drive of stuff. There's a lot of, geographic, data laws that exist. Rather, it's, in fact, I heard of one through, one of our major clients who's one of the largest credit card processors in the world. This isn't just a US or Asia or European thing. You go to countries like South Africa, they have very, very serious, data residency laws. So you just can't do these things and just think that it's okay to move data out of country if it's not okay. So how do you deal with the technology sides of these things along with the legal and business side of these things? And so let me put it in more of a visual perspective. So the way this works is EDB as a company acquired a group called Second Quadrant a couple of years ago. Second Quadrant came out with a tool called bidirectional replication. So BDR was originally open sourced about 6 years ago, and then it has continued and evolved into Postgres distributed. And it isn't just about how we can bring something like this, active users across 2 different regions. In fact, in my picture here, I've got US East 2, and I've got US East 1, and I've got a primary and a secondary, and what we call is a witness node. A witness node is necessary because when you think about having consensus, if there is a conflict, if something happens, what is going to automate the breaking of that tie kind of thing? Along with, there's a lot of best practices that have come out of the world of this idea of active databases. Things like commit at most once, transactions, so you don't get into split brains. Split brains has been this problem with active databases since I was your age, fellas. And the way you solve that is by having this commit at most once split brain type of personality. But it also allows you to make it to where if something happens within a region, it can fail over automatically. It can also make it to where if you lose an entire region, which will never happen at AWS, I can tell, but if for some reason something happens, all the users can get pushed off into that other region until the other one comes back up online. I'd like to highlight, this is a moment of just a moment of pause for me. We've been talking about in the world of databases since the dawn of databases, this idea of failover. Failover is what we talk about. But we never talk about how do you rehydrate? How do you get back into a normal state? How do you get back to this? So if I had this, how do I get back to this? Well, that's one of the things we build in this as well, is once that whole zone or region comes back up online again, we're capturing all the changes that are going on, and we will automatically rehydrate that region or zone behind the scenes. No one's the wiser. You don't have to do anything. That to me is a major advantage here, because if you go try to do this with anything else, and I mean any other database technologies, that rehydration process is painful. And also I've seen where these other cloud vendors that aren't nearly as good as AWS, obviously, they talk about the rehydration process, and when they're done rehydrating their Postgres offerings, they aren't even in the same zones or regions. I mean, it's like you can't get back to the state you were in before.
No.
So heaven forbid. So, this is what we're talking about. Now, what does this look like? Well, what this looks like is if I go over here into my big animal console and I go into my clusters, and I pre-created this cluster, I call it flight reservations. So in the spirit of for some reason, this has been the week of me talking to a lot of airlines around the world. So if I think about in this example, I created a data group in US East 1, a data group in US East 2, and then I have what we call a witness node. So if an entire region goes down, as I showed in this drawing over here, I've got a witness to make sure that everything is kosher in this region. I got a witness node to make sure this is kosher in this region. But if I get to this point, I need to make sure that this witness is covering off that when this one comes back online again, everything is working properly. Now, there is a whole lot more that we could get into in terms of, well, how do you deal with serial data types, and what do you do? The what ifs on these things are, really in the weeds. But let me take a moment to kind of talk through this real quick. Is, within this, how you operationalize this is I can go out here and I created this environment that I have in US East 1 and US East 2. I have a witness node in US West. And then I have connection strings for East 1 and East 2. You could also put a DNS over the top of this thing. So if we just wanted one connection string for both, there's ways we can be creative there. And then I also like to highlight too that we give you flexibility to decide what you want each node to look like. Well, what do I mean by that? Well, let's look at US East 1. US East 1, I'm just using a little 2 CPU R6i with GP3 storage, where in US East 2, I put in a slightly larger computing environment and I'm using IO2 storage. So we let you be a little more heterogeneous in your architecture, because maybe how you're going to do active-active isn't just half of the users on one and half the users on the other. Maybe you would do a 60-40 split or 75-25. You have some sort of methodology because, and again, nothing against my friends at AWS, but clients want to spend less money. So how do I balance what I need for resiliency, horizontal scalability, and covering off on those what-if scenarios we've been talking about with economics? And that's where it comes into play around the flexibilities we give you.
Wow, looks like EDB has really thought out a lot of these features, and this is giving me flashbacks to my grad school days where we had to think of the what ifs. What if this goes down? But I do want to ask one question about that
Sure.
diagram that you showed.
Yeah.
You mentioned about how like an entire region may go down, which won't happen. But
Never,
what if,
never happened.
but is there just one single witness that is overseeing every availability zone? And what if that witness goes down? Then how do you resolve?
Good question. So, for instance, what if so a witness is there to handle conflicts? So if a witness isn't there and there's no conflicts, that's fine. In fact, more often than not, you don't get into many conflicts. You truly don't, because a conflict literally is looking at that UTC time code down at a fraction of a second. And what if one of us is changing the zip code of Tom Rieger while someone else is changing the phone number of Tom Rieger? That's not really a conflict. It's just two different columns. So even if a witness is lost, it doesn't affect the readiness of the entire cluster. Because you're right, in this picture here, what are the things that can go wrong? Well, there's a litany of things that go wrong. But that's where we've covered off on, we have the answers to that based on, pick your problem. Because what also happens is, now how do we operationalize this and how do we minimize the evasiveness on the developers in how they write the code over the top of this, so that if a failure happens, that the code doesn't need to know anything. It's something you do, and that's why you see this blue proxy box. The blue proxy box will take care of that. And we also use, inside of a region, we use AWS's load balancers to do things in there as well. So we're always looking to use the most native cloud tools to do the cloud work for us. Because what happens here too is, the way that we built this out and the way that we have organizations use Big Animal is, we run in their account. So if I am, I'll Delta Airlines, that's not an example, but I'll just use that because I just got off one of their airplanes a couple of hours ago. If I'm Delta Airlines and they have a big AWS spend, let's call it, $100 million, they want to go and consume things using their discounts and the regions and everything else. We run in that account. So as a client is using their R6Is and their GP3s and their S3s or backups, that's using their negotiated prices. So we're always making sure that it's running in the security paradigm, in the VPC, in their account, in the regions of their choosing, so that it's as easy as possible to make the transition.
Awesome. I think Parvinder had something to add.
Yeah.
Which I interrupted rudely.
It was Tom covered it when he said the backups are also according to what customers would need, that they can put it in S3. So
yes, so there's a whole nother architecture conversation about Big Animal that I wasn't. Well, heck, we got it. We're on here for some time. I can do whatever I want, can't I? So let's. And I'm sharing my screen, so I'm going to try to be as minimally evasive as possible. So, because the way this works, here's kind of my de facto Tom Rieger drawing of how this works. We run, this blue box is your account in AWS. And what we do is we put the small control plane in here, again, the T-Mobile store color, the EDB control plane. And what it does is it does the 4 fundamental verbs that you expect: provisioning, monitoring, administering, and updating. And you come up with some combination of server types that you want in your account, and it pulls into those what you need from a compute, storage, block storage, blob storage, load balancing, and so on perspective to create that database environment. It then can use AWS CloudWatch as a monitoring tool of choice. I do mention the other logos up here because it runs the same way across all the clouds. So I used to work for Snowflake, so it's kind of like that. But Snowflake works in their own stuff. That's a very bad example, but we're cloud agnostic here. But we have found that doing things with the AWS components and the AWS computes are as cost effective as I've ever seen. So kudos to you, by the way. And then you're able to create some combination of replicants that you want. We have faraway replicants, and then even things as mundane as connection pooling, as I mentioned this earlier, is if I have a read-write node here on my left, I have a read-only node here on my right, and then what I do is I use the PG bouncer, the native Postgres connection pooling technology over the top of this, and then I can have any number of connection strings depending on if I want it to be a pooled connection, like your casual user type, or the power user type who needs a direct connection. And that's why over here in this example, where I created my Oracle migration, you see these connection strings. So here's where I have a connection pooler. So I have a read-write connection pooler string, a read-only connection pooler string, and then a direct read-write and a direct read-only. So you're able to engineer things to scale as necessary from a compute, RAM, storage, network, and then especially around at the database layer, how do I scale database size, database workload, and database concurrency that makes sense?
Yeah, that does. I have a question from chat.
Yeah.
This you might have covered it, but Rexon asks, so you'd mentioned in the heterogeneous, database where you can have multiple write instances.
Yes.
So will you lose data if the bigger region goes down? So if, let's say,
So you have control. In the end, you can have control over how eager the replication is or not. So sometimes you may call it synchronous or asynchronous, because there's always that balancing act of, do I want higher performance and take on some potential risk, or do I want slightly lower performance and always know that I have synchronous data consistency? If you're, an ATM transaction at a bank or a reservation system for a hotel or an airline, you probably want to have zero data loss. So how do I make that be as effective as possible? But it's worth noting too, if I go back to, let me go back into this drawing. That's why we also have 2 nodes in 2 different zones in each region. You can also have, for instance, inside of a region, you have these 2 be synchronous. You see my mouse going back and forth. But then you have this connection between the regions themselves be asynchronous, because the chances of an entire regional outage is very, very low. The chances of a zonal outage is maybe not quite as low. So how do you this is all, so a neighbor down the street from me here is an actuary, and the people who actually define like the insurance tables. This is like an actuary's dream at trying to figure out those worst case scenarios. What are the chances of, is it a zonal outage, an entire regional outage? And then how do I make sure I have as close to zero data loss and zero downtime as possible? Now, there's other ways we can architect this too. We can even have like a third a second shadow node inside each region to cover off on what may or may not happen. Because again, if we're worrying about zonal outages, maybe we want to have something in each of the 3 zones. So we want to make sure that we give clients that balance of, resiliency with risk, but all the while, if what you're dealing with is a desire for zero downtime and zero data loss, that is our objective. What I just showed you right here, by the way, we're right now at 99.95%, and by spring, we'll be at 5 nines in terms of what our SLAs will be offering in AWS across regions.
Wow, that's amazing.
Good. So Tom, before we go ahead, let me just put it that there would be few people or new people joining in
Yeah,
on our
anybody,
podcast.
sure.
So anybody or anyone who is joining now a little late, we are on Howdy Partner with EDB, where Tom is providing more information on the journey of migration from Oracle to Postgres, and also on how Big Animal, which is an offering for EDB, how it's helping customers on the enterprise level. I'm Parvinder Singh, a partner solutions architect with AWS, and Bhavye as well. He's the partner solutions architect, so we're co-hosting with Tom.
I'd also like to state too that if someone is trying to get off of Oracle, one of the reasons they're still on Oracle is because of the resiliency conversation. So these actually work very much hand in hand in what's going on. And if you're on an Oracle rack or next to data box and you have this, this desire of near zero everything, data loss, downtime, pick your measure. That's where this idea of how I can help organizations get off of Oracle, get onto AWS, and strive to have these types of scenarios come up where we can cover off on doing cross-region active Postgres. That really covers off on a lot of what we see organizations needing to feel that they can sleep at night. Because again, as organizations are trying to spend less and do more, because again, for new people on this call, one of the things I say all the time is any organization looking to replatform a database, you be able to do 3 to 4 times more work at 3 to 4 times less money. So how do I make that possible for you? And oh, by the way, still innovate, right? So digital transformation is the sum of all the things we've been talking about here, which is the do more for less and still have innovation, still have AI and ML, and pick your buzzword for 2024 today. I challenge you. But all the while, making sure that one of the things you gain is this area of rolling upgrades, automatic recovery of failures. There's a lot of automations that even don't exist on premise. We want to make sure there are gains there by organizations around the world when they think about doing these things. And this is kind of a drawing that gets into how it works going round for round, because again, one of the challenges that people don't want to have anymore by going to the cloud is I don't want to run on old stuff. So how do we make sure you don't run on old stuff? Whether it's compute, whether it's on what version of Postgres or database you're on, it's getting rid of the old stuff. But with that, then there's kind of a final leg of the three-legged stool that I like to talk about, which is how do we measure success? So my favorite analogy here is so my sister is a bigwig in Hollywood, and I like movies. And there's a moment in the movie Ford versus Ferrari, for those who remember the movie, right? Henry Ford wanted to go take on 24 Hours at Le Mans and Ferrari to win it in the 60s. And he sent Lee Iacocca, then a VP for him, to visit Carroll Shelby in California. Carroll Shelby made custom cars that were really fast, and he won 24 Hours at Le Mans. And Henry Ford basically said, what if I give you a blank check to go do something really fast? Well, I don't know about everyone on this call or my friends at AWS here, but I don't know of any of us who get a blank check to do anything. So we can't always be the fastest at something, but we also don't want to go out there and be the cheapest. I'm not going to go out there and turn on 2 CPUs of a V3 compute with a GP3 storage with no IOPS and think that I'm ever going to get the performance characteristics I need to be successful. So there's this, how do we measure, what good looks like? And that's what I want to talk about last. So for my friends at AWS, and I think the number's up to 60 now, by the way, this is about a 6-week-old chart. AWS offers 55 different 8 CPU sized environments. But the challenge from a database person perspective is, what's the right one? Well, the right one really is a function of money, because I can tell you the right one I want is the most expensive one. It's the fastest chip with the most RAM. I mean, because we all want the fastest. But we have to be real here. I am not Henry Ford giving blank checks to Carroll Shelby to make a car for me. I need to be very pragmatic in making my choices from a compute perspective. And then there's storage. Now, I mentioned the other 2 cloud vendors up here on purpose because they make this stuff complicated. Google has more storage now than ever, including this thing called Hyperdisk. Azure's got this thing called Ultra Disks that we can all sit down and have adult beverages, and we can have conversations about that. But AWS, I mean, you have a lot of choice. So what is the right choice? Because each choice you make has a financial result to it. And you don't want to just benchmark components. You need to benchmark the platform. And so I also, having a minor in statistics and quantitative methods from college, I've learned a long time ago there's liars, damn liars in benchmarking. But in this case, there's a tool called HammerDB that I like to call out for everyone's use. And when we're done here, if you reach out to me, I will send you my scripts where I've done a lot of these things. But if you go out here and look at HammerDB, what's really cool about it, besides its price, because it is free, is you can benchmark other databases as well. So it gives you a standards-based database modeling tool, and it runs what they call the Transaction Processing Council, the TPCC benchmark, which is OLTP driven, and it also will run the TPCH, which is data warehousing driven. And then you get a number out the other side, transactions per minute. It also gives you this thing called number of orders processed per minute. But it allows you to get a measure, because I was at a client earlier today, and somebody in the room said, you realize where we seem to go the most is our cloud calculators tool to figure out what we can do. So everybody talked about going to the AWS calculator to figure out, well, what should we do before they ever even logged on, kind of thing. So we need to be cognizant of price and performance and component decisions. So in saying that, if anybody ever uses HammerDB, it basically simulates a transaction processing environment that does 75% reads and 25% writes. So it's not just going to be reading out of the cache, and it's going to take the database to task, and it's going to see how well the CPU and the storage work together and so on. And you can scale it up in terms of database size and scale it up in terms of concurrency. But the beautiful thing is it gives you one number out the other side, transactions per minute. So if I get transactions per minute out of one side, I know what my platform costs out the other side. Well, guess what? I can now think to myself, well, what is my cost per transaction? How am I being most effective in my use of this platform to process work? And so so I've never shown this chart to anybody. So to my friends at AWS, I hope you don't mind. We are totally experimenting here with everybody on our Howdy partner call. So I took HammerDB, and on Big Animal, I took the R6i compute that was 8 CPUs and 64 gigs of RAM. And on the bottom axis here is I want to try different storage choices, right? GP3 or IO2, and you can have a certain number of IOPS and or throughput decisions to make. And I wanted to see how well they performed, which is the blue bar, so higher is better. But if I then divide my monthly cost of that environment into my performance, I get a cost per transaction. So lower is better. And you can see here where, for anybody who wanted the cheapest platform, they would say, oh, I'll just go turn on IO2 and set it to 2,000 over here. And you see it got the worst result and the highest cost. Well, that's not the right answer. But at the same time, you could also get kind of this false sense of things a little bit here, like, well, I'll just keep bumping up my IO2 storage, because if you look at the blue line here, it kept going up. But guess what? Because of what the total platform cost, the cost per transaction inched up a little bit as well. So how do you define what optimal is? Now, this is also, by the way, using 1 year, no upfront, reserve pricing in US East 2 with list pricing for storage, and having a constant there across everything. The only variable I had out of all of this was the storage I used on the back end. And also I ran them 3 times, and these are all averages. So this isn't just, I try to minimize the statistical anomalies. But the moral of the story here is, where do we get to optimal in all of these things when it comes to a platform? Because I was just at AWS reInvent, which, by the way, everybody, was the biggest show I've ever been to in my life. It was 65,000 people in Vegas. We took over Vegas, folks. I mean, honestly. And there were I don't want people to come to the AWS reInvent conference or talk to AWS or think that AWS is giving them buyer's remorse. I don't want them to make a decision on something and say, oh my gosh, we have to claw this back into our data center because we made the wrong decision. I want all of us to make the right decision. And the right decision sometimes isn't as complex as a technology decision. Sometimes is as simple as choosing the right components to bring together to create the right result. So that's why I wanted to mention this around this idea of how to measure success. I was told I should write a book. I've ran about 1,000 benchmarks, by the way, of HammerDB. So I have obviously a litany of data behind me here on this bookshelf you see behind me, with more data. But the moral of the story is, what's the methodology that makes sense for your organization to try to make a measurement decision? Because it isn't just using FIO to measure performance of disk. It isn't just seeing which compute is the newest. Is it the newest Cascade Lake 7s or is it the old version 4s? I mean, it's you can drive yourself crazy to this because of things as mundane as this. I have so many choices out there. You have too many choices. I say this too because, in fact, I just presented at a user group meeting last night in Dallas, Texas when I was down there. And there's this dichotomy around, and again, I'm dating myself for my AWS friends on the call here. Back in the mainframe days, you would run something, and basically at the end of the job, you had a job, and the job cost money. You could get a printout, and the output was a printout, and the last page was your job cost. And it was how many pages, how much ink, how many spindles turned, how many instructions in the mainframe, and it cost 57 cents, Mr. Rieger. But back in those days, developers wrote code knowing to be efficient. And then what do we do in the 90s and the 2000s? We have now just gone hog wild writing code. No one knows what an instruction is. We don't care. And that is especially true when it comes to databases. Good SQL, good queries, and so on. Now that we get in the cloud, everything is so much more complicated. This costs a certain number of cents, and you get IOPS and throughput and what's the right storage. And so I think we need to take a step back and think to ourselves, as we're moving off of Oracle, as we're looking to create resiliency inside AWS, and as you're trying to make those right component decisions, how do we get to that point of being the most effective stewards of our employer spend in Amazon as possible? Because that's the only way we're all going to be successful.
You mentioned about reInvent, and it got me remembering about the keynote given by Werner Vogels. I don't know if you got a chance to
Did not see Werner.
catch that.
No.
So he was talking about how cost optimization and trying to optimize is a lost art now. Ever since we have the cloud, we just back in the day of mainframes, as you mentioned, we really had to think deep about getting the most out of our hardware and our software. But now it's like with a click of a button, you can just get more data, get more IOPS, and that art has sort of been lost over time. And it's great.
You're talking about frugal architect, right?
I think it's reasonable to say too, because sometimes I had a client, put this in my face going, well, we get a 66% discount from AWS for things. I'm like, I bet you do for your compute, but I bet you don't for your storage and a lot of other stuff. So, I think he's absolutely spot on. Is we forgot how to be more frugal in our writing of code because we don't have to anymore. Because I can go, if I go turn on, I think about what it took for me to go turn on this big animal environment with, in this one that I created right here, I've got, so in this one right here, I've got, 4 CPUs and 32 gigs. Let's bump it up to 32, right? Let's scale it up. I've got IO2. Oh, I need 5 terabytes now, and let's set that up to 15,000 IOPS. Oops, not 150,000. Let's hit save. Now, odds are I may blow up my quotas, so it may come back in error. But the moral of the story, too, is the cloud gives us now elasticity. Back in your data center, you were a slave to whatever your data center people gave you, and it was that size forever. Where now you could say, let's start at 2 CPUs. Let's go to 32 CPUs. Oh, let's go back down to 16 CPUs. So now you get this opportunity to treat the internet a lot like electricity into your house. If you need to turn on the air conditioner and the blow dryer and the oven at the same time, you can, and you just consume that many more kilowatt hours of electricity, right? It's compute, it's storage. But when you don't need it anymore, you turn it off, and you're not paying for less. And I think the world needs to understand how to manage that paradigm, but all the while still make sure you cover off on resiliency and security and, disaster recovery and all these typical things we've gotten used to worrying about, along with just how do you do more with less, right? It's got to cost less. If it doesn't cost less, we all failed at our job. So I want to make sure that we all realize this is a conversation that we are all a village at doing this together. And I don't want to, and in the spirit of, for those of you who don't know, being that this is the Howdy partner, the Howdy partner conversation. I did grow up in Oklahoma, which is a state in the U.S. that I guarantee you most of you have never been to, or if you have, you drove through it very, very fast. So the one that looks like it's a frying pan here north of Texas. And the moral of the story here is we need to keep things, simple. We need to keep things going together. And in the small town in Oklahoma where I grew up in, here in Northeast Oklahoma, I can tell you, you go I-40, for anybody who wants to ride a Harley Davidson across America and go on Route 66, you'll see where I grew up. But there's three categories of people in a small town. The people that aren't nice, the village idiots, and everybody else. And I never want to be the village idiot. So we need to make sure that as a village, that we are all together in this together and making the cloud successful for our employers. And that's why I wanted to make sure as you think about how do you make this easier on yourself, fit into how it works in your organization, and have the net. And if the net result saves money and it does more for your company, then it's amazing how many things are forgiven, right? It's, if I could do more with less, trust me, my employer will be like, we'll just pay you more, Tom. Well, I'm still waiting for that to happen, by the way. Actually, I did get promoted. You didn't mention how I got promoted this week.
So you just got promoted.
I just got promoted. So, but in saying that, how do we drive this resiliency across this concept of active Postgres so that you can move those tier 1 workloads? Let's not forget, we're sitting here at almost 2024. And you know what? IBM still sells a lot of mainframes. Why? Because even those mainframe workloads, they couldn't quite get onto open systems over the last 25 years. Well, now we got the cloud. How do we make them ever feel comfortable to move those tier 1 workloads to AWS? True tier 1 workloads. Hyatt reservation systems, United Airlines reservation systems, these things that, are highly secure, highly volatile, have, enormous amount of things around them to make sure that they never go down. How do we drive that kind of resiliency potential? Do I think we're there yet as we're chatting on December 13th, 2023? I don't think we're quite there yet, but we are getting there.
Yep. Could you mention I think in reInvent as well, now mainframe migration programs within AWS?
Yes. Well, and we have a partner who has a great tool that can take things right out of DB2 on a mainframe and drop them right off into Big Animal. And part of what it does as well is it can also identify what data you shouldn't migrate. Maybe you say, I only want to move the last 5 years worth of data up into the cloud and put the rest off into an archive. Because the more old data you put up into the cloud, the more you're kind of just opening yourself up into bigger problems. So how do you, as you're making this move into AWS, into this resilient environment that, will hopefully never go down, and we've figured out how to measure success, how do we make sure we even make that more successful by only moving there what we need to? So that's kind of what I had for, I would call it prepared statements and impromptu demos for everybody. By the way, one of the things I do want to highlight is if you want to try Big Animal out, you can just go to biganimal.com, and you see here you can create a start free, and you could try it out right now in AWS. You can also go into, let's see, I'm going to use I'm an employee here at EDB and use hold on, I got to give it a fingerprint and a thumbprint and a retinal scan and a pint of my blood. But if I go into AWS here, and I go into my marketplace. Actually, before I go, since we have time, so our big animal offering, I say it runs in my account. So it would run in my native AWS account. So hold on, let me close a few things here. So I have this environment here running in US East 1 and US East 2. Let me go into US East 2, and you see it's running on an R6i 2X large. So if I go in here into US East 2, and I look in my EC2 environment that is running, you can actually see here that here it is. Here is my compute running in my account. So the moral of the story here is the things that we use to build out Big Animal in your account, you can actually see for yourself. Please don't play with them. But it allows you to have a degree of transparency and control that is maximized, because we want to make sure we maximize the automations for you, but minimize what we take away from you. We want to maximize your control. And that comes in a lot of forms. But if we want to talk more about Big Animal and how it can help you make that move to the cloud and cover off on these resilience conversations and these Oracle migration conversations, I'm the only Tom Rieger in Minnesota. So, yep. So if you see this ugly mug right here somewhere, you know you found the right guy in Minnetonka, Minnesota.
Awesome. I had a few questions prepared, Tom, if you have
bring
a
it
minute.
on.
So first of all, you mentioned a lot about what EnterpriseDB offers in terms of its tools and technologies. But other than that, what sort of other, like, let's say someone were to avail your services, what sort of other, offerings do you have or support do you offer to your customers?
So I always like to use my website as a reference point, because then people can follow along and take that away from this conversation. So when we talk about our products, obviously Big Animal and what we are doing in the cloud of the AWS is one of our premier offerings. But we can also do things on premise with you. In fact, our offering is built on our Kubernetes operator of Postgres. So that strives to give us faster uptimes, better resiliency, better failover. Along with, we have different plans depending on what is important to you. Along with, when I think about that trifecta of services, education, professional services, and training, I mentioned we have all kinds of training available. We have our support organization is 150 engineers worldwide doing nothing but Postgres. Some of these people in our support organization are named contributors to Postgres. When we find a bug in Postgres or a security vulnerability, we immediately donate it back into the community. Thus, the engineer who fixed that bug is a named contributor to Postgres. So we have people in our support organization who are that granular at doing things. I also want to highlight too that, one of the things that, I've highlighted a little bit, but I just want to bring up, and it's going to be a really ugly thing. So my apologies right now. I'm going to open it up and I'm going to zoom in on it. So I told you it's going to be ugly. Our support organization, when we say we support you as a client, it isn't just Postgres support, and it isn't just troubleshooting support. We give you support for all of the other open source projects around and with Postgres. So you think about connection pooling, backup recovery, monitoring, replication, and then you start to get into things that run inside Postgres as extensions or as foreign data wrappers. We bring break fix level support to these things because we're involved in these projects. So our level of support comes with a lot of dimensions to it, both in terms of width, in terms of the what we cover, the depth in terms of the people we work with. We have 51 named contributors to Postgres. So if they don't know the answer in support, they'll go to the people in our engineering or CTO organization who wrote the code. So it's a lot like you getting, I would say, vendor level support, but support from database vendors have really gotten bad over the last 20 years, but support like it should be back in the day from the vendor, but from an open source perspective, at a break fix perspective. But there's other things we don't have control over. We give you troubleshooting and guidance for obvious reasons, because they're just open source projects we don't have control over, but we can sure help you be successful with them. And this is true whether it's in our Big Animal offering or in your data center and how you do things. Because one of the things that I have found too is maybe in your efforts in migrating off of Oracle, maybe you want to start by migrating that off of Oracle on-prem and then make the shift into the cloud. Because making those two major shifts all at once, that's a big, big deal. And especially if it's a big system. I worked with a very large insurance company that's headquartered down the street from me here in Minnesota. And they moved 180 terabytes from on-prem Oracle up into AWS on our advanced server all at once. So there's nothing in the middle. This is thousands of concurrent users, very high resiliency requirements. And they ran into stuff that if they just did it all on-prem first, at least did the DevOps and regression testing on-prem first, it probably would have gone better. But they were in a hurry. So that's, I think, if I think about what we bring to the table here, it really is giving you that depth and breadth of services, support, and education, along with, of all the engineers we have in here, we're doing a lot when it comes to the cloud. We're doing a lot when it comes to Kubernetes. We're doing a lot when it comes to the other toolings around Postgres, besides just Postgres as a core database. It's all these other things, this ecosystem. In fact, one of the things we're very active in here too is, and to me, my favorite part of any website is docs. What engineer doesn't like documentation? So all of our docs that are here, you could see all the documentation for Big Animal. We talk about Postgres distributeds right here. We talk about our advanced Postgres that looks and smells like Oracle is right here. But you can see that we do a lot in terms of adding into this open source world third-party integrations for a litany of reasons. Backup, data movement, developer tools, security, on and on and on. Because it, in the open source world, sometimes that ecosystem comes together by accident. We try to bring more product management and engineering around that to make sure that it is running the best it can against Postgres.
Awesome. I have one more question. So
anything.
let's say today you're a customer who wants to migrate to Postgres or Big Animal specifically.
Mm-hmm.
What would be the 3 tips you would give them before they get started? Or what advice?
1, do you know anything about Postgres at all? Because odds are when you're doing that, you're a SQL Server person, you're an Oracle person, heck, you're maybe even a DB2 person in the mainframe. I don't know. So making sure you kind of understand what you're getting into. It's kind of like when I was renting a car in Dallas this week, they offered me an electric car. And I thought to myself, I don't know if I'm ready for that yet. I'll just take something with a good old-fashioned gas tank because there's a bit of a learning curve there. I felt uncomfortable. How do you get through that initial, uncomfort when it comes to understanding Postgres? Reach out to me. Let's start there. Secondarily, why? Why do you want to move to Postgres? Why do you want to move to the cloud? Is it an edict from the top down? Is the CIO saying Oracle just audited us again? It was horrible. I never want to see that person again. What is the why in some cases? And then let's help come up with a plan, because people can make emotional decisions. But if those emotional decisions don't have some sort of business value or financial backing around them, it's never going to go anywhere. One of the things that the cloud has done is it has brought a transparency of pricing that now makes everyone an accountant. Back when it was just, I had an 8 CPU, 64 gigs RAM, and 10 terabytes in my data center, and it cost me a fixed amount, every year, and it was static. Nobody cared about what stuff costs. You focused on the technology. Now that we're in AWS calculators were, I would challenge the single most hit web page on AWS's website is your calculator, because everybody's going there to figure out, how do I get to optimal? How do I get to that right answer? And it's really not that easy. So come and have a conversation. Let's understand what's the motivation. Let's understand how well you may know something. And then let's also understand how we can get you to the right place financially, while you are having resiliency and monitoring, and you have all these expectations, because Oracle's expensive, but they give you some great tools. Oracle Enterprise Manager is a very elaborate tool that gives you a lot of, whiz-bangy monitoring of things. How do we get you to that same level of monitoring and resiliency and performance so that you're able to sleep at night? Kind of a long answer, but you gave me a generic question.
Yeah, that's true. Awesome. You have any questions, Parvinder, or we can wrap it up, and we can, if you want to plug in anything, Tom, the stage is yours.
Sure. I would like to mention that, and I mentioned it once. I'm not sure as people have either left or come back, or went to mix a martini because it's a Wednesday and we're doing this little. It's pitch black here in Minnesota, so I figured pitch black is maybe it's Bourbon Wednesday for you. Don't know what everybody does, but it's you can start very easily with Big Animal. But even if you just go turn on a trial of Big Animal, you need to have something you want to do with it. So if you want to just maybe start with a conversation, just reach out to me. Like I said, I am. I'm using my screen share to my advantage. So there is my email address. There is my phone number. If you happen to live here in Minnesota, let's bundle up, go have coffee. If you want to come visit Minnesota, wait till next May, after the snow is melted.
Or bring your own shovel.
Bring your own. Actually, no. Actually, so we've got to let's have a little fun here. So I do want to highlight that. Let's see. I think it's this clip right here. Here we go. So I will. Oh no, it's this one right here. I will teach everyone how to run a snowblower. So you come visit me January, February, March. We'll go outside and we'll do this in my driveway. This is my Nest camera out of my home office right now. So we'll if you don't feel you need to go to the beach and get a suntan, you come visit me. We'll talk about Postgres. We'll talk about the art of the cloud and why open source, and figure out how to go from there. So so that's all I really had for everybody.
Awesome. Thank you so much, Tom, for joining us and sharing your amazing insights and great graphs and presentation. It was all amazing. I'm sure I can.
I do this for 35 years. It's in fact one of my favorite props is always keep a couple of floppy disks up here to give some perspective.
Well, I haven't seen those in years.
Oh, don't you dare! Don't you dare! Hold on, I've got a Raspberry Pi sitting here too, so at least I But no, in all honesty, I think there is this massive macro. I mean, I saw it at AWS, 65,000 plus people. Just this massive move to the cloud happening right now. I just want to make sure that people do it at a tempo and with a bit of rigor, financial and technical rigor, that they're successful. Because again, I said it once and I'll say it again. I don't want buyer's remorse. I want people to be successful in making these moves. And as I said once, and I'll say it over and over again, everybody's done paying for Larry's Island. So how do we help them get off of Oracle? In fact, I just had these made. This is a T-shirt where it's the Postgres elephant, and we've got Oracle at bowing to the king elephant.
Wow, shots fired. Yeah.
Yeah.
So anybody who wants a T-shirt like that, it's amazing what ChatGPT-4 can do for you in terms of making graphics.
Bedrock. I think you mean Bedrock. But
You mean Bedrock?
Right?
Yeah. Sorry, my mistake. See, you all have 500 different things to choose from. I'm just a database guy, so.
You got
I'm curious. So anybody who's still on here, put in the comments 1 to 5. How was the session? 1 was horrible. 5 was this is freaking awesome. So just type a 1 to 5 in the comments. That would really be helpful. Or I see you have a survey link here, so thank you. All Monty's on my Christmas card list. Thank you, Monty. We're big into Christmas card lists here in Minnesota. Ice fishing. I think you two need to come visit me to go ice fishing.
Yeah, that's something I've only seen it on the TV.
Or March. Come here in March for the polar plunge. So
polar plunge.
Polar plunge. Hold on.
Exactly what it sounds?
It is exactly what it sounds like. So this is, people line up and they cut a big on a lake, and they cut a big section of the lake out to have a little hole in, and you jump in, and it's like 15 degrees outside. So do the polar plunge.
Yeah, I don't know what that, Chief.
Come on, it's how do I put this? It creates a hardy constitution. There we go. I feel like I'm waxing Will Rogers right now, for those of you who know my older reference. But thank you, everyone. And like I said, anybody has any questions at all, you can find me here.
Awesome. Thanks a lot for joining us. Join us again next week on Howdy Partner, same time, 2 p.m. When we welcome our next partner, that's smartbots.ai. So that partner is all about creating automated chatbots for customer experience and customer support. So be sure to attend that one. I know we all like AI and generative AI. It'll be really fun. So thank you all and see you next time.
Take care, everybody.
Thanks, Tom. Thank you. Thanks, Bhavye.